Join the movement. Go all electric with Pure Electric.
Just like to begin today by acknowledging the Gunditjmara people, traditional custodians of the land on which we meet today, and pay my respects to their elders past and present. This is our home. It's located in the small town of Koroit in southwest Victoria, just at the western end of the Great Ocean Road. The house achieved an 8.1 NATHERS star rating in the last calendar year, was operationally carbon positive. This presentation is going to run through a few of the key elements that helped us achieve our goal of a sustainable home that's comfortable, inviting, and also delivered within our budget. The first element that I wanted to go through was the passive solar design that we incorporated in the house. The very first part of the build was finding a block of land that included the long orientation of the house to the north, to allow the house to be set against the southern boundary to give maximum winter solar gain opportunity from the north. This resulted in a house that doesn't have a classic Australian backyard, but instead provides the long yard along the northern side of the house. We utilised thermal mass in the design via a polished concrete waffle pod slab that also included a 50mm insulation to the underside and perimeter of the slab and was used to capture the heat gain from the northern orientation of the site. The main living area roof design utilised a reverse truss to allow the living space to have high ceilings and windows to the north. The roof design also included for the eaves to match the window selections to ensure summer shading of glass and winter solar gain. A pergola structure was included in the north external area that has fixed louvers for shading and eventually a deciduous vine for further summer shading. This photo was taken in February just after their installation, showing the perfect shading effect of the timber louvers on the windows and doors, as well as on the eave on the highlight windows above. Lastly, the windows were sized and positioned with eaves and shading to maximise summer shade and winter light and heat gain. We worked through this with the NATHERS assessor to right-size these based on the modelling outcomes. Small southern windows are included to allow for cross breezes, with high-level northern windows on electric actuators to further enhance the cross-flow ventilation and purging of the house. The garage is located on the western end of the house, along with a hit-and-miss brick wall that are used to block the late summer sun from the main living areas. The second element of the house I'd like to talk about is the building envelope design. The building envelope can be considered as the boundary of the conditioned spaces from the outside as well as other non-conditioned spaces in the house. This is a key component to the design that we work closely with our designer builder during the design to achieve the actual performance of the house that the NATHERS rating had indicated. As part of the brief to the builder, we included the requirement for a vapor permeable wrap to the roof and walls of the house. This has now become a code requirement since we built for our climate zone. The wrap was taped and sealed to make a continuous barrier around the entire envelope of the house. You can see here the batten system that we installed on the outside of the wrap to create a ventilation cavity to allow the outer layer of the wrap to dry as the vapor moved out of the house. In addition to the wrap, we chose to use uPVC high-performance double-glazed windows and doors for the entire house. These are generally, with the exception of 2 awning windows and some sliding doors, tilt and turn style windows that provide high opening areas when they are used for naturally ventilating the house, as well as fantastic seals when closed to keep the hot or cold out. The builder also did a fantastic job installing these to make sure each window was taped, corked and sealed to maintain the airtight barrier around the envelope of the house. Finally, all external and internal walls and ceilings have the maximum insulation installed that we could achieve. We've also included insulation to the underside and perimeter of the polished slab to maintain as much of the heat and cool as we could capture. Internally, we had a lighting design that has no internal downlights, with surface or wall-mounted fittings only used, to minimise penetrations in the ceiling as well as not disrupt the insulation above in any way. Towards the end of the project during the fit-out, the house was pressure tested via a blower door test and an insulation review was conducted via thermal cameras. The outcomes of these was that no insulation required adjustment or addition to the house, and the house achieved an air change rate of approximately 2.5 air changes per hour, which was a little bit better than what we had targeted, as we were looking for between 3 and 5. The third element of the house design that I'd like to talk about was the use of the all-electric for the appliances and services to the house. For heating and cooling, we've installed ceiling fans in both living areas, as well as all 4 bedrooms. A 6 kilowatt reverse cycle air conditioner has also been installed, but this is just in the main living area. An electric towel rail was also included in the family bathroom due to it being located on the southern side of the house. However, we've not found a need to use it in the 1.5 years we've been here. The cooking appliances in the house include a 90cm induction cooktop and a 60cm oven. And lastly, our hot water is provided by a 315 litre standard heat pump hot water unit. To complete the all-electric design, we had installed on the house a 4.5 kilowatt PV system, which has been sized just to cover the consumption of the house based on a fit eventually being phased out. The system has just completed its first full calendar year in 2023 and has provided us with a net positive usage versus production of just over 380 kilowatt hours. The last element that I wanted to talk about was the importance of a low maintenance home. We decided early as part of our brief that we did not want a home that included a large commitment to ongoing maintenance. Externally, that resulted in minimal natural timber, and where we did, like on the pergola, it was left to grey off. The external northern cladding was chosen to be a WeatherTech sheet product to provide the preferred aesthetics as well as longevity. We had wanted to achieve the look of timber windows to provide the warmth to the home, and found that the uPVC timber looked to be a great alternative to standard timber windows to get both the thermal performance and look we wanted without the maintenance requirement of timber. The other external walls included the use of ColourBond steel and brick to the south and west facing walls, as this is the main direction of the winter weather in this area. ColourBond fascia was also selected so as to prevent repainting requirements and replacement due to any rotting out of timber. The builder also installed a cement sheet lining to the perimeter of the slab insulation, where it was exposed around the perimeter of the house to protect the insulation. Internally, we had a mechanically polished concrete floor that doesn't require any sealer, so won't be needed to be reapplied in the future. All skirting was natural pine, not MDF, which is both a more natural product, but also more robust to the wear and tear in a family home. Lastly, our rear kitchen prep bench is stainless steel, which was due to its length, the only material we could get in a single piece without a join. And with an integrated sink and rear shelf, it's removed any silicone and tile cleaning point at the back of the bench or around the sink. That's the end of today's presentation. Good luck with your own planned projects, and thanks for watching.